This video is all about chain rule. It's all about chain rule. So now, chain rule is like, let's say you have a function, let's say f function of x, and this f function of x has a function u function of u, so for a function of v, then v function of x function of x. So if you want to find the derivative of this function x with respect to x, you first find the function of this f with respect to u here times, this is v, times the derivative of u with respect to v times the derivative of v with respect to x times the derivative of x with respect to x. So this is a chain rule. It's a chain rule. So now it's just like saying, now let's say you have a problem. Now let's say you have ln x raised to power 7. Now this ln x is a function. Now raised to power 7 is another function. Now for us to do this, we first start with the outer function. Now let me assume that let u be equal to ln x. Now if u is equal to ln x, and the whole of this function, let the whole of this function be y. So y will be equal to u raised to power 7. Now the derivative of this function, which is the derivative of y with respect to x, now will now be the derivative of y with respect to u times the derivative of u with respect to x. This is the chain rule. Now for us to do this, now to do the derivative of u with respect to x, you now have ln x. The derivative of ln x will give you 1 over x. The derivative of y with respect to u will be, now this is use a power rule, so this will be 7 u raised to power 7 minus 1, which is the same thing as 7u raised to power 6. And since u is equal to ln x, we substitute it here because we want everything to be in the variable x. Everything should be in terms of x. So now we have 7 bracket open ln x raised to power 6. So this is this. Now substitute it in here, substituting the u, the derivative of y with respect to u here, which is 7 bracket ln x raised to power 6 times this, which is 1 all over x. So the answer will now be 7 into ln x raised to power 6 all over x. So that is the final answer. Now let's look at the next question. Now the next question is, you have the derivative of a quotient that is 2x minus 3 divided by 4 plus 5x raised to power 4. The derivative of this now, let's assume the whole of this inside is equal to, let's say t is equal to 2x minus 3 all over 4 plus 5x. And now we assume that u is equal to 2x minus 3 and v is equal to 4 plus 5x. Now, the whole of equation will say, the whole of this equation inside there will say is y. So y will now be equal to, now in terms of t, will be equal to t raised to power 4. Now, let's look at it now. Let's do the derivative of this. So now the derivative of this y with respect to x, which is derivative of the whole thing here, is equal to the derivative of y with respect to t times the derivative of t with respect to x. Now, but inside here, there is a quotient. Inside the x, inside this place, there is a quotient rule that we're going to apply. Now, the quotient rule, if you have, now you have t to be equal to u all over v. Now, the derivative of t with respect to x will now be, now the derivative of, let's say you say v, the derivative of u with respect to x minus u, the derivative of v with respect to x divided by v squared. So this is the formula that we're going to use now to get the derivative of t with respect to x, which is this. Now for us to do that, we have our v to be this. So this is the derivative of t. Now let's now work this one out first. The derivative of y with respect to t will be, now this is the power rule. You have 4t raised to power 4 minus 1. So using the power rule, you now have 4t raised to power 3. So the whole of this is 4 times the t is this. So replace, we need to write this in terms of x. So now you now replace it with 2x minus 3 all over 4 plus 5x, which is our t raised to power 3. So that is it. Now we have gotten this. Now the next thing we're supposed to get is this. So applying the rule there, now what we're going to do is, now let's now go to the next page. Now we are looking for the t, the x, which is equal to v du the x minus u dv the x divided by v squared. Now our u is equal to 2x minus 3. Our v is equal to 4 plus 5x. So the derivative of u with respect to x will now be 2. Now the derivative of constant is 0. So now the derivative of v with respect to x will now be 5. Because the derivative of this constant is 0. So you have 2 and 5. So now substitute anything here, you have v to be this. So you have 4 plus 5x times, okay, that is u prime, which is 2, minus this, which is this, that is 2x minus 3 times what, 5, divided by v, which is this, 4 plus 5x all squared. So the t all over the x. So that is it. So now we're going to write this as 2. Now we open the bracket, 2 times 4 is 8. 2 times 5x is plus 10x. 2 times 5, this is minus 5 times 2x will give you minus 10x. Then minus 5 times minus 3 will give you plus 15. Divide by 4 plus 5x all squared. So this will cancel out. You now have 8 plus 13 will give us 23 all over 4 plus 5x all squared. So this is the value for this. So now applying this rule, say the chain rule, which is the derivative of 2x minus 3 divided by 4 plus 5x all raised to power 4 will now be equal to, this whole thing will now be equal to the same thing as the y, the x, which is the same thing, because from here we say the whole of this is y, so it's just the same thing. So now it's also the same thing as the y all over dt times dt all over dx, which will now give us the y all over dt. This is what we get, which is 4 into 2x minus 3 all over 4 plus 5x all to the power 3 times this value, which is 23, divided by 4 plus 5x all squared. Now this can be rewritten as, now 4 times this will give you 4 times, that is 92, give you 92. So we have the final answer to be 92 in bracket 2x minus 3 raised to power 3 divided by 4 plus 5x raised to power 5. So this is the final answer. This is this final answer. So now the next question is find the derivative of this, which is the square root of x raised to power 3 plus 7. Now it's just the same thing. Now this can be rewritten as the square root. So now this can be written, the square root is raised to power half, so plus 7 raised to power what, half. Now this can also, in straightforward form. So since we have been doing all this, so with this we can be able to now if we want to get the derivative, do the derivative of with respect to this function inside, which is now b. Now as a power rule, you have 1 all over 2 into x cubed plus 7, keeping this the same. Then now this 1 over 2 minus 1 times the derivative of this one inside, which is now 3x squared. That this one is 0, so that is it. Now this will now be 1 over 2 minus 1 is minus half. So we now have 1 all over 2 into times x raised to power 3 plus 7 all raised to power minus half times 3x raised to power 2. So now you now have this to be 3x raised to power 2 all over 2 times x cubed plus 7 raised to power half or minus half. So now this is the same thing as saying 3x raised to power 2 all over 2 square root of x cubed plus 7. This is the final answer. So this is the final answer to this problem. Now let's look at the next one. You have the derivative of 1 all over x squared plus 8 all raised to power 3. Now, this is the same thing as saying the derivative of this x raised to power 2 plus 8 all raised to power. So this is, according to the law of this, it should now be minus 3, the law of indices. Now, the whole of this, so now we can now do the derivative of this, the derivative of this with respect to this function inside here, which is, now that means this becomes a power rule. So now, using power rule, you now have minus 3 into x squared plus 8. So minus 3 minus 1 will give you minus 4 here, times the derivative of this, which is 2x. The derivative of constant is 0, so this will now give us minus 6x divided by x squared plus 8 all raised to power 4. So this is the final answer for this. Now let's look at this other one, the derivative of this sine cube tan cos x cube. So this is the same with what I just have been explaining now. Assuming the whole of this inside here is u is equal to tan cos x cube. Now, and this one inside here is equal to this v. V is equal to cos x cube. Then this one inside here is x is equal to x. So now, but when you look at this now, the whole of this is y equal to what? Y is equal to the whole of this, which is sine 3u, because the whole of this is u. Now u, writing u in terms of v, u will now be, the whole of this is v, so u will be now be tan v. Now writing v in terms of x, if x in terms of x, v will now be cos x. Now I would have used t here, so that because this double x here, so let me use t here. Now, if you will now do the derivative of this based on this, now what we are going to have is dy dx. Now, sorry, this is supposed to be, okay, let me still do it like that. Sorry, with respect to u, will now be this. We'll now use we first use power rule. Power rule, this, let's say, let me write it sin 3u, the derivative of this. So this is the same thing as saying the derivative of sin u into 3. Now, if we want to do the derivative of this, we'll do as power rule. You have 3 sin u, then the derivative of this one inside, you have cos u. So that means the whole of this is the derivative of this with respect to u. Then now, the derivative of u with respect to v will now be sec square u, square v, sorry. Then now, the derivative of v with respect to t this will now be minus sine t. The derivative of t with respect to x will now be 3x squared. Now, I would love to clean up here, but no, let's leave it like that. Now we now have, if the answer now will now be, if you say the derivative of y with respect to x will now be the derivative of y with respect to u times the derivative of u with respect to v times the derivative of v with respect to t times the derivative of t with respect to x. So this 1, 2, 3, 4. So this is 3 cos, sorry, 3 sine. Now there is a square here. 3 sine square u cos u, and then this is sec square v, then this is minus sine t, then this is and this is times 3x squared. So we now have 3 sine squared. The u is tan cos x squared, x cubed, tan cos x cubed, tan square x cubed, now sec square v is cos square, cos v, which is what, cos t, which is x cubed, times, this is still times, this is times. Now the next one is then times minus sine t, which is x cubed, times 3x squared. So this is the final answer. So, but we can still do it in another form. Let's say you say derivative of x into sine 3 into tan cos x cubed. So this can be written as the derivative of this sine tan cos all raised to power, let's see, all raised to power 3. Now this is the same thing as saying this 3 now is power room. You just say 3 sine. Now write the whole of this. Square. And then you now differentiate this one, which is cos the whole of this remaining constant, which is cos the whole of that remaining constant. You now have now Then differentiate this, the whole of this remaining constant. So you have sec square cos x cubed times differentiating this, the whole of this remaining constant, that is sec sine minus sine x cubed. Then differentiating only this now, you now have 3x squared. So when you check, it's the same thing. This square now is the same thing with this square here. This cos is the same thing here. This sec, same thing. This minus is the same thing here. Then you will now have, now differentiate the inside one, which is this. So that is the final answer. Now, please subscribe to my channel, like, comment, and share the video. Thanks.